Hello everyone and welcome to the latest episode of the Modern Brewer podcast with me, your host, Chris Lewington. We're back to the topic of purchased CO2. I was recently speaking to a mate about this. She's not in the industry, and I was explaining that during fermentation, large quantities of CO2 are produced, which is just let out to the atmosphere. And then we buy CO2 back at inflated prices to then later use in the process. And she was like, oh, so the CO2 fermentation produces is bad. I just respond, actually, no. In fact, it's purer than the CO2 that we later buy for inflated prices. She was confused. And when you have to explain this situation to someone outside the industry, there really is little justification. I mean, in fairness, that hasn't always been the case. Carbon recapturing, until recently, has been limited to brewers producing 100k hectoliters a year. And nitrogen generation has been around. It hasn't always been commonly used in breweries. So in episode 15, we discussed how nitrogen generation can reduce your purchased CO2 usage by 85 to 90%. In this episode, we're going to discuss how recapturing your carbon dioxide from fermentations can, in theory, produce over 100% of your CO2 needs. Interestingly, I was with Felix from Small Beer the other day, and he made an excellent point. Not only does relying on purchased CO2 naturally directly cost the environment, but actually, as an industry, we're funding the synthetic fertilizer industry, one of the biggest polluting industries of modern times. So with that heavy note, let us continue on our quest to eradicate purchased CO2 in our industry by exploring one of my favorite technologies, produced by one of my favorite companies, Dalum Beverage Equipment, and their carbon recapture unit. Before we get into the episode, I want to take a moment to talk about friends of the podcast, Simpsons Malt, the largest family-owned malting company in the world. Their 160-year passion for quality has given them global respect amongst both the brewing and distilling communities. As regular listeners know, I'm a huge champion of sustainability, and Simpsons Malt's 2023 sustainability report highlights the company's outstanding commitment to people and the planet. One of the biggest takeaways from the report for me was actually the vertical integration of their supply chain. This incredibly unique approach to malting means they forge long-term relationships with their malting barley suppliers by working directly with them, shortening the traditional malting supply chain to simply farmers, maltster, brewers. I mean, having long-term relationships with their farmers makes total sense, right? It means Simpsons Malt has total control over the barley that enters their malting sites and also enables them to work with farmers to drive sustainability throughout the supply chain. I'm going to link the sustainability report in my show notes. Please check it out, and remember, choosing suppliers who are reducing their emissions, in turn, reduces yours. Okay, so back to the episode. This is going to be a record for the show. The first time there has been 4 speakers all at one time. I hope everyone enjoys it, and as always, please let me know what you thought of the episode. You can always reach out to me on LinkedIn, Instagram, or if you're at BeerX in the UK in March, I'll be there, most probably in the same blue shirt that I always wear that happens to be the current logo of the podcast. So here we go. With me for today's episode is Frederik and Kim Dalum from, you guessed it, Dalum Beverage Equipment, and Jan Paul, who's with us to give us insights from his Dalum unit, which was actually the first ever commercial unit. So without further ado, hope everyone enjoys the episode, and let's welcome to the show Frederik, Kim, and Jan.
Thank you very much.
So if you guys just want to start off by introducing yourself, let's keep some law and order in this. So let's start with Frederik.
Yes, thank you very much. Well, my name is Frederik Dalum. I am a sales manager at Dalum Beverage Equipment. I started working with Dalum basically ever since we had the first unit ready for sale. So I've been with Dalum basically ever since the start of this.
Excellent. And Kim, would you like to introduce yourself?
Yes, my name is Kim Dalum. I'm founder and CEO of Dalum Beverage Equipment. I have decades of experience delivering engineered solutions to brewers worldwide.
Amazing. And Jan?
Well, hello. I'm a brewing consultant. I've many years of experience as a production guy. I was in charge of a brewery in Denmark, the brewery where we have installed the Dalum CO2 Recapture plant. And currently I'm working abroad. Right now I'm in Georgia. I just came back from Cameroon, so I'm traveling the world, doing consultancy for breweries, but also a bit of sales work for our CO2 recovery plants.
Excellent. Wow, that is a journey of a CV there from Cameroon to Georgia. Love that. All right, so let's just kick this whole thing off with what is CO2 recapture and how does it work?
Well, CO2 recapture is capturing the CO2 produced during fermentation and the CO2 used purging tanks. So we purify it, liquefy it, and transport it to an external storage tank for storage purposes. Option for larger breweries have been around for many years, so this technology is completely new for craft breweries. There were really no options for a solution, CO2 recapture solution for craft brewers until 4 years ago. So one or two suppliers have entered this market with simple systems, skipping the liquefaction step, just compressing the CO2 into pressurized vessels. This way they keep the oxygen in the CO2, as this the only way to remove oxygen is by rectifying the liquid CO2. It is crucial to remove this oxygen, as the oxygen can be very harmful to the product.
Yeah, absolutely. What's interesting to me is when I was working in breweries before, we were quoted quite a substantial amount of money for a system that was capturing carbon. Why has that now become more affordable? And what was that system compared to the one that Dalum has created?
I can answer that. You can say traditionally, CO2 recovery plants for larger brewers has been system built from standard components for huge compressors, CO2 compressors for industrial gas companies, with the purpose of recovering CO2 maybe from natural sources or from you can say petrochemical sources or from urea, really huge systems built from systems available today in the market. And I would say the thinking, if you have the background building CO2 recovery plants, you will think to build it in this way. And actually there is one competitor in the market who are building systems based on, you can say, the traditional way of thinking. And this system, it's still the size of a house, right? Because you build it of building blocks that actually take up a lot of room, and they are very expensive. Normally you will have to pay millions for a system. We took the other approach and said, okay, what's actually needed? What's actually needed in a small brewery? You need something compact and you need something affordable. So the only choice to actually meet this demand was to build a system completely from scratch, based on our own proprietary technologies, like our own compressor, our own very compact condenser, and even the control system is a lot different and based on a small smart PLC.
So it's interesting you said that the previous systems were from basically industrious gas collection, which were trying to be applied to the brewing industry. So what were the components that were making that the size of a house? Because I agree, they were also huge. I've seen the floor print of them; they were colossal. So what did you do to take that? You made your own compressors, etc. But how does that actually differ from the previous technology?
Well, I mean, we took a strategic look at it, you can say, and also in terms of technology, we took a fresh look at it with, you can say, fresh eyes, and looked at what was actually available in a brewery, and how can you make it simpler? So there's a lot of things we don't have we don't have a refrigeration plant in our system. We don't have a refrigerant. We use external cooling source, and in order to liquefy the CO2 at higher temperature, at temperatures where coolant is available, we had to go pretty high in pressure and design a 3-stage compressor capable of producing 45 bars of pressure. And it's not available in the market, but we found a way to build it, and to build it compact using one drive to run a 3-stage compressor. We haven't seen that done before. And moreover, we built it of stainless steel component, all food grades, FDA approved material, and moreover, the compressor is variable speed. That means we can adapt to any capacity of CO2 produced from the fermenters below the maximum capacity, of course. And in this way, we don't need a balloon in front of the system. It makes it a lot more compact and simpler. And we run a bit of overpressure into the compressor, which works on the compressor like a turbocharger. So it actually saves us energy at the same time that it saves us energy and space.
Yeah, that's really fascinating. And I've got to say, the first time I ever saw the Dalum unit, I was blown away by the size of the floor print of it in comparison to what I'd seen previously. How long did it take you to design this? Like, what was the process from design to first unit to trial to market?
Yeah, it was actually, for me personally, a nice journey, because the background is I held executive position with this distinct global engineering companies like Krones, Alfa Laval, and Union Engineering, who is now part of Pentair. And I decided in 2018 to establish Dalum Brewery Equipment with the aim to help craft brewers to save money and become more sustainable. And the reason I choose to change career in this way, despite I have been working in the industry for many years with, you can say, more commercial brewers, was the consolidation that actually took place in the industry. Because before the consolidation, I really enjoyed this world encircling and generous culture with a passion for beer. It was a culture of hospitality and working with great people who allowed to have fun and have a beer with the suppliers. At the same time, it makes our suppliers walk the extra mile for the customer, and it sparked great innovation in these times. But with the consolidation, I would say this culture that I was a part of and really enjoyed so much, it vanished. But on the other hand, it has been a pleasure to see how the small brewers saw, how they develop, the same type of global soul that love the culture, love the product, love the beer, and just want to make good beer, innovation, work together with suppliers, and really focus on the target to make a great beer. So that was actually the background why I shifted, and it was not clear for me it should be CO2 recovery being the main product, but I was working with technologies for recovering beer from spent yeast or surplus yeast, and I was on a good track, I thought, but the brewers was actually not really keen of the idea of using this surplus beer from yeast in the good product. So some of the brewers I work with, especially one here close by, asked me with the background I have, why don't you make a CO2 recovery unit? And you should listen to customers, and that's what I did, and took what I had on the drawing board and started to get serious about it. And it took about 2 years until we had the first prototype running here at a local brewery, and soon Jan in Svaneke Brewery came after and bought what was actually the first commercial sales from us. And Jan can tell more about it. It was a really nice journey as well. It wasn't without you can say challenges at that time. It took many iterations to get it right, of course.
Yeah, absolutely. I mean, I guess there's quite a lot of trial and error of this being the first of its kind. Was there any major things that you had to solve out of interest?
Yeah, the entire purification process, how to get it right, took some iterations. We started out with, we remove most of the impurities with the water scrubber in front of the compressor. But we intended to remove more impurities with water with a high pressure scrubber after the compressor, which was, I would say, it's a nice idea just to remove impurities with water and having no chemicals or anything in the system. But it was simply too hard to make water run and clean the system at 45 bars without the risk of having it going into the dryers and condenser. So that one we gave up, and we had other iterations using activated carbon. But I'm pleased to say today we managed to have a system. We have no consumables in our system. It's a simple purification system running on 95% the water scrubber in front of the compressor, and a set of dryers that we can regenerate. The desiccant last for a couple of years, so there's really no consumables you have to replace every month or so. And we have a simple condenser with a very efficient rectification of the liquid CO2. So today it's very simple. It's actually a very lean system with no maintenance or consumables you have to replace on a monthly or weekly basis.
Yeah,
which is actually you can say the nature of large-scale industrial plants. There are normally carbons and other chemicals you need to replace on a regular basis. But it's not practical for craft brewers. The large brewers or the industrial systems will not. Maybe they have a machinist working on the system in 3 shifts to look after it, or engineer looking after the system, even on duty in weekends. That's not possible for craft brewers. So we were forced to make it simple and develop new methods that requires a lot less maintenance, a lot less attendance. So it's only a few minutes a day you need to look after the system.
Yeah, which is a pretty substantial point. A question I've been wanting to ask is, what are the requirements for a craft brewery's sort of fermentation to be able to warrant having a CO2 recapture system? For example, if a brewery is brewing a lot of 3% beers, presumably that's going to be more of a challenge to have the enough CO2 to recapture, or is that not a concern?
Well, of course, there would be producing less CO2 with when they brewing with a low alcohol percentages. So we do see that some of our customers experience issues with becoming completely self-sufficient. But as you mentioned in your previous podcast, combination with a CO2 recovery unit and a nitrogen generator is basically the best combination of becoming completely self-sustainable.
Mm-hmm. Yeah. Do you have a calculator, or how do you work out, how does, let's say, a brewer listen to this, think, well, I want to know if I can be 100% reliant on the CO2 that I recapture? How would they work that out?
You'd say for every gram of alcohol you produce 1 gram of CO2. So that's a pretty easy way of calculating this.
Yeah, there's a lot of people going on Google right now going,
Yeah, exactly. So if anybody wants me to calculate this, we have dozen of spreadsheets for this.
Yes.
So I'll forward a complete study on this if.
Yep, we can attach those to the show notes, or we can figure that out. So there'll be something
Sure.
in the show notes for anyone listening, so you can work out if or how much CO2 recapture you can rely on.
Yeah, just as a rule of thumb, we used to say you can recover between 2 and 3 kilograms of CO2 per hectoliter of beer you produce, and it depends on, of course, the alcohol percentage and how quick you are to connect the tanks after they are ready for CO2 capture. When the oxygen level is low enough, it needs to kick in, and if you do that accurate, I think we have customers coming up to almost 3 kilograms per hectoliter.
Great. That's a nice number to work off as well.
Yeah.
Jan, you said you had the first commercial unit, I guess, after the trials. How was that project for you?
That was a great fun for me. I love developing things or help developing things. My father was an engineer, so I grew up with these problems, and he would come home and tell me about, oh, this is working finally, and he'd be so happy. And I felt the same spirit when Kim came and with this new equipment, and we had to try a lot of stuff. Some things went not as we wished, but it was great fun, and really enjoyed it. And yeah, we succeeded in the end. And now we've been running this machine for a good 3 years. I've been a part of this 2.5 years. I left my work half a year ago, and it was fun. That's the best word I have. And also because the goal was so cool. I really loved the idea. When I built the brewery back in 2007, I wanted CO2 recovery for sure, and I of course contacted the well-known people in this field, and they were all laughing. Under 100,000 hectoliters per year, this is not doable. And I always tried to find a way to recapture CO2, but then luckily I met Kim, and there was no way back.
And how much from your brewery did you manage to replace with recaptured CO2?
All of it. And we have a surplus of CO2. So we bought roughly, or we use roughly 27 tons a year, and we produce 35 tons. So we have a good surplus, which we fill in gas cylinders and sell to our draft beer customers. So it's super good.
So you actually managed to turn it into a revenue stream as well as a...
Totally.
That's amazing.
I mean, this is a super good business case. The savings alone made this break even will occur in 2 years. Like after 5 years, we already obtained break even, and that just by the savings and the created value that we sell on gas cylinders. I mean, it's great. I mean, we were quite good at in our production to save CO2, to not use more than absolutely necessary. We're quite disciplined with this. I need to mention also that when I built the brewery, I installed a nitrogen generator for pressurizing tanks before bottling or kegging. so to not have to use so much CO2. So all of this helped, plus a great deal of discipline during the processing of beer.
Yeah, that's really fascinating. So you had that combination of nitrogen and CO2.
Yes, yeah, nitrogen from the start and CO2 the last 3 years, and in combination, I mean, we're like, yeah, we earn good money on this.
Yeah, that's awesome. Just a quick tangent, because what's interesting to me is a lot of brewers don't use nitrogen for pushing out tanks, so they're
Yeah.
using CO2. Is that CO2 capable of recapturing through the Dalum unit as well as obviously fermentation CO2?
Sure, I mean, the CO2 from fermentation or whatever CO2 you apply can be recaptured. You just, as Kim said, need to be below 0.8% in oxygen content, otherwise the pressure in the condenser rises too much. That's it. Then basically anything can be used, and it's of the highest quality. I have a little burette, so I do measurements, and yeah, there's absolutely no objections to use this for whatever you want.
Yeah, which is actually a really fascinating point for me. How do you check the quality of this CO2? And I mean quality in terms of quantity of oxygen in, and also microbiological or just off flavor quantities. How do you manage and measure that as a brewery?
So we have, as I mentioned, this burette where we basically let the CO2 flow through some caustic, and then there will be a tiny bubble of gas left, which is measurable, which are the other gases than CO2, nitrogen or oxygen or whatever it may be. This is measurable, very easily carried out, takes 5 minutes. That's the purity of the CO2. It's a lot better than the normal food grade CO2 you buy, and oxygen content is seriously low. And as for microbiology, there is basically no chance that any carryover of microorganisms should occur. As one thing is that the gas that leaves the compressor has 120 degrees. That's one thing, and also the very high pressure that's applied is another thing. And there's even a sterile filter mounted in the system later, which can be replaced with intervals. So there's no chance, and I think Kim will agree that no one has ever heard of microbiological carryover through a system like that.
Yeah, okay, maybe you could just add on to that as the mechanical reasons for why microbiological stability is not a massive concern.
Yes, I would say that's actually our least concern with you can say the purity of the CO2 coming out of the system, because the process is quite rough to any microorganisms, and we have before the condenser we have a sterile filter that can be replaced, as Jens said. It can also be regenerated. I mean, it can be sterilized as well, if needed, or you feel to embed that in your quality assurance system. So we are quite confident, and it's not. I mean, it's not a concern you see in general with CO2 recovery, because even in the liquid CO2 there's no oxygen, and there's a high pressure and very low temperature. Of course, there are anaerobic bacteria. I know they are around, but it's not something. It's not something you should be concerned about, and the sterile filter is 100% guarantee that nothing is going through. On the other hand, there's an array of gases and components that we don't want to have in the clean CO2, in the liquid CO2 in your tank. There is regulations for us as regulatory standards for CO2 in food. It's E290. CO2 is called E290 as a food additive, and basically the purity should be 99%, which is very easy to actually provide if you have oxygen or rectifier in your system to get rid of the oxygen. But other requirements is of course from authorities that it's free of benzene and ammonia, and this is not something you see in fermentation gas, so it's not a big concern. But when we're commissioning a system, we test with gas detection tubes for an array of these gases, and we have started to do it for benzene and ammonia, despite we know we will not see anything, but it's documented. It's free of these components, and we have an array of about 10 other impurities we test for, and for people who are more interested in the details on that, I will actually refer to an article in Brewer International from October that I wrote in there with all the details on the purification process. Some brewers, they buy the tube system, the gas detection tube system, for their own quality control, and some others are happy with the burette, and by doing what we call a bubble test in water, which is actually, I would say, a quite safe method for fermentation CO2, because any odor or any off taste will be quite obvious for a human to detect. Actually, I would say our senses can detect smaller concentrations of some of the harmful gases, as you could call it, in the CO2, which could be some DMS or maybe other sulfur components. But I would say this is the simple way to do it, to do a bubble test, and you will definitely be fine. We have in the system, we have an inline dew point sensor. It's rating, I would say, on average 90-80 C, which tells us we have very dry, bone dry CO2. But it will also indirectly tell us that the dehydrators are working fine, and they are cleaning the gas for other impurities as well. So this is actually a good documentation that you have the low dew point, and the gas would normally be cleaned with our system in this way. All this is documented. We have an online dashboard for all our machines, so all process data is logged in the cloud. You can say it's stored in the cloud, and you can retrieve the data and use it as documentation in a quality documentation schedule.
That leads on quite nicely to what is the brewer's control points for recapturing CO2, and how do they manage that? I know you mentioned there's a dashboard. Is there an online portal as well that brewers can use?
Yes, the dashboard is an online, you can say it's an online documentation system where we store all process parameters from the machine. So that's a good way to document at least the dew point and other process parameters, and it's a nice tool for troubleshooting as well. But if you want to really document the quality, I would say the dashboard is indirectly documenting. But if you want a direct documentation, we recommend once a week you do a burette test, or many brewers also have an instrument, an handheld instrument for measuring dissolved oxygen in beer, and many of these instruments can actually measure oxygen in gaseous CO2, vaporized CO2. And if a brewer have this instrument, we recommend to to take a test from the tank or a tricock on the system once a week, because it's a very good documentation. And what we see, we don't have the instrument ourselves, we use the burettes, but we see very low values like 5 to 15 parts per billion of oxygen, which we are very proud of. We still don't dare to guarantee this very low level, but this is what we find. So this test once a week, a burette test or a test with an oxygen meter, that guarantee your CO2 is free of oxygen. And in addition, do a bubble test, because that tells if there are any odors in the system that you'll be able to detect in a beer. And if you want to really document, you can say impurity by impurity, it is possible to use the gas detection tubes to document, you can say, the ppb levels of other components. There is a standard for, it's a commercial standard, it's not a regulatory standard, it's from the ISBT, International Society of Beverage Technologists. They have a list of, you can say, maximum values of a lot of components in food grade CO2. And if you want to be really detailed, you can go by line and document the level of impurities for each component. I would say it's overdoing it if you just do the purity test and the bubble test once a week.
Mm-hmm. That's really interesting. It's not actually a lot of control points, really, although I would say always essential, because it's such an important thing, the CO2 that you're using in your brewery. And one thing that most brewers probably do take for granted, including myself over the years, is that CO2 you're getting is clean, because it's already been checked. So now the onus is on you and to monitor and maintain that. From a brewery operative standpoint, what are the requirements? You need a Dalum unit, but what else is required? Because I assume at some point you're going to have to hook something up onto the sidearm so that you can actually harvest this CO2. Is that hard pipe? Is that soft pipe? And then where is the gas being stored? So just what are the requirements, and how does a brewery operative look at it?
Yeah. In our case, I mean, in all cases, you will, of course, need the unit. You need a collection stations where you can connect the tanks, the blow off of the CO2 into this pipe that will go into the CO2 recovery unit. You can use hoses or fast mounted piping. I chose the latter because I want things to be somewhat neat and CIP-able and nice to look at. So that is one thing. So hoses from blow off to collection station, then a pipe to the actual foam trap, and then from there it goes into the actual recovery plant. And then there's the piping to and from the CO2 storage tank. So liquid CO2 goes into the storage tank, and from the storage tank, obviously the gas formed CO2 for usage in brewery has to go back. And also, if you have a cylinder filling station like we do, we need a pipe back with liquid CO2 so we can fill the cylinders. So that is the requirements. We had a CO2 tank beforehand, obviously, like many medium-sized craft breweries have, and we bought it off the CO2 supplier, which was a bit of a costly project. But the thing is, we were not sure if we would become CO2 sufficient like right away. So we wanted a back door. So if the math pointed in that direction, but we wanted to make sure. So we had a bit of a stock of CO2 to start with, and we never ever bought any CO2 again. But yeah, that is the reason why we kept the tank we had and got the project a bit more costly. Kim can deliver the whole thing with a new tank for a brewery at a better price.
So if someone already has an existing CO2 tank, can that be used for the Dalum unit?
Almost any tank can be used. However, if a brewery buys a new tank from Dalum, it's adapted for CO2 recovery, so it's a bit more efficient for the process. We tend now to build tanks capable of holding a higher pressure because it reduces the flash gas coming out of the tank when we flash into the tank. So we can run with almost no losses, and we build the feed lines into the tank in a different way with smaller pipes, so we don't have to insulate, the very big flanges and stuff you normally have for truck filling a tank. So there are a few small, you can say, few small adaptations on the tank we implement when we sell a new tank, but basically we can use any other tank for storage if the brewery have a tank, or if the gas company owning the tank is willing to share it in this way.
Excellent. Another question: what happens when you've got your CO2 hooked up to your tank and the tank over ferments, which is quite a common thing in a craft brewery? I've seen it and been a part of many. So what happens, and how does the system deal with that?
Well, yeah, we see foaming. We actually mount a foam trap on basically all systems. Sometimes it's just a simple foam trap without foam detection or anything, because when we run a bit of overpressure, it's actually less foam we have, and it's normally easily can say turn into liquid or beer when it comes to the foam trap. We also sell more sophisticated foam traps, which is of course an added cost. But in most cases, the slight overpressure reduces the foaming considerably. But I would also add that there are other things brewers can do to reduce foaming, because it is a mess to have all the foam in the system, and most of our customers, they actually found ways to not have foaming, even by running the same amount of beer in the tanks, and there are ways to regulate the temperature, the amount of yeast you add. I'm not a brewmaster myself, so I don't want to tell customers how to do it or what they can do, because they are the experts in their beer, but they usually find ways to basically get rid of foaming from the tank. So it's very unusual we see foaming now. Maybe Jan, you can add in. I think we have never seen foaming in Svaneke brewhouse into the system.
We also had some of our small fermenters. We had over foaming happening, but as Kim said, it's all about avoiding it. I, for example, aerated a tiny bit less if there was a risk for over foaming, so that helped it a great deal. I've never had any foam carry over into the foam trap. I check it on a weekly basis to see if there should be anything. Nothing ever. So that will make you think twice. You don't want foam and organic stuff in your piping to the. Even though it's CIP, well, it's work, and if you can avoid that, avoid it.
Yeah, which actually leads me perfectly onto the next point. How often and how do you clean the CO2 ring?
Can I just add a cute little story before this question, because we had one customer who, they had a nice signature beer. It was they was adding a bit of sugar to the wort, and they had a lot of over foaming. But when we added the foam trap just close to the tank, just right after the fermenter. And during the first CO2 recovery we did, I think we had to empty out the foam trap. I don't recall if it was 2, 3, or 4 times, and it was 200 liters every time, and it was basically good beer. So of course it made them think, could they do something about it? Because why lose 400 or 500 liters of beer turned into foam in the process? And they found their ways, and basically there's not foaming, or not a lot of over foaming doing this beer.
That's fascinating. So what about the CIP of the main? How difficult is it, and how often do you recommend generally that it gets done?
Yeah, I installed the pipe in a way so it is easily CIP-able. I have a CIP program for pipe systems, mainly the Wattway, water cooler. It's basically the same program. I just connect it differently on a panel, and that's it. And I do it, I would say once a month is enough. I really don't have any foam carryover. Never detected any growth or any microbiological problems from that side. So once a month is fine for me. Then I also take, and I also CIP or clean all the hoses that I use for connecting the tanks. There are times when we have 6 to 7, perhaps even fermenters going on the same time. So we bought a lot of hoses just for this purpose. So things are separated, and so it depends. But like once a month is totally sufficient in our case.
That's really interesting.
I can add a bit maybe from working with large brewing groups as well, where we have seen, very different systems for CO2 collections, very, very huge pipes, sometimes not standard steels. It can very often, I have seen glass fiber pipes being used for CO2 recovery, and the cleaning procedures has maybe been 1 or twice a year to clean the piping, and it was done, not by flushing with SIP liquid, but simply by high pressure cleaning the tubes by sending in a nozzle on a hose and clean it out, whatever was left in there. But so it's not super critical, and normally there's not a lot of contamination issues with it, because you have a CO2 atmosphere in the piping, and of course I would say, like Jan, clean it if there's something to clean, of course, because it's nice to have a clean system with, if you have, foam and stuff in the system by accident, it's good to have it clean out, and it's nice to see that your piping is free of foam and any kind of what is it called, particles or anything inside.
Yeah, really interesting. It sounds all like it's not a lot of maintenance, to be perfectly honest. Cleaning, I think every brewer would always set up everything they buy to have some form of CIP possible. It's just interesting to know how often that is, especially with the foam issue. It probably acts as a catalyst for people to help solve the foam issue rather than use it as a reason not to recapture CO2. A point I asked in the nitrogen generation episode, and one I definitely want to ask here, Frederik, you might be able to help me on this one. So if I'm a small or medium sized craft brewery, what are the options to purchase?
We at Dalum do not offer any leasing or rental options, but we do have collaborations with different companies in different countries. So if you're, for an example, if you're a UK brewer and wish to lease a CO2 recovery unit instead of purchasing it from us, we have a partner in the UK called Ninkasi that offer leasing and rental options for our units.
And for a brewery trying to calculate how much capital would be required to buy a Dalum unit, how would they go about understanding what is the capital requirement?
Well, we have 4 different sized units. The smallest unit has a theoretical compressor displacement of 5 kilograms an hour. And this unit is about 32,000 euros. You'd, of course, need a collection station, a storage tank. These in total, on the smallest unit, it runs up in about 45,000 euros. If you're going up to the larger model, it's about 60,000. The second largest unit is about 100,000 for the full system. And the largest unit, it's still in the development stages. We haven't delivered one yet, so I can't say for sure. But yeah, it's about 120, 130,000 for a full system.
And what are the so you said 5 kilograms, theoretical value of 5 kilograms for the smallest unit. What's the sort of medium and large sizing in terms of theoretical compressor?
Well, our largest is 30 kilogram. The second largest is 15 kilogram, and the second smallest is 10 kilogram.
Okay, that makes sense. So, I mean, everyone who was listening earlier has the calculation to work out how much they would need, and now they can work out how much is possible as well. What's the smallest in terms of volume output brewery have you installed in?
Well, the smallest unit has been installed in 5 breweries so far, and I believe that the brewery with the smallest capacity is about 2,000 hectares.
Interesting.
So we commonly say that CO2 recovery is financially feasible from 1,000 hectoliters and up.
That's fascinating. Okay, yeah, that's really useful because, of course, with it being a business decision, there's going to have to be a return on investment here.
Yes.
As much as there is an environmental return, what would you say is a standard ROI to expect on a Dalum unit?
It really depends because let's say if you buy the largest unit, this unit is designed for breweries with a production between 25,000 hectoliters to 50,000 hectoliters. So it's quite of a big jump. So let's say if you're a brewery producing 25,000 hectoliters and you purchase the largest unit, the return on investment time would probably look like 4 years. But if you produce 25,000 and you're not expecting to expand your production, you're going to stay at 25,000, you can buy the second largest unit as it suffices your production capacity, and that way you can basically cut down the return on investment to 2 years. I've seen very remote breweries located in mountains actually have a return on investment time on 4 to 6 months.
Wow.
So it really depends on the price that you procure your CO2.
Yeah, which is not only expensive, also unstable, which is the one thing that we all dislike about purchased CO2. Yeah, that's really, it's fascinating. About 1,000 hectoliters is like where the affordability cuts. And just to reiterate, when I was working breweries, even Kim said it earlier, if you're not making 100,000 hectoliters, don't even think about CO2 recapture to now 1,000. That's such a substantial difference that really encapsulates nearly all of the market now, not in terms of the volume produced totally, but in terms of the amount of breweries, which is really important, I think. So yeah, just totally fascinating. And yeah, I'm like really impressed by everything that you guys have been doing. So absolutely huge congratulations on my behalf, because I think it's awesome for the brewing industry and obviously pretty fantastic for the environment as well.
I mean, you are referring to the environmental impact, and I'd just like to leave with some numbers on what we have achieved so far. Let's say when we recover 1 kilogram of CO2, we basically save the environment for 2 kilogram of emission, because it takes another kilogram of emission to bring 1 kilogram of CO2 to a brewery from a commercial source. And we would say in average, our machines, they make like 30-40 tons a year, and this is you can say compared to 70 to 80 tons reduced emission, which is about, for a European car, it's what 70 to 80 cars are emitting per year. So, I mean, what Jan was doing in Bornholm was actually equal to get 80 cars off the road a year. Now we have our nameplate says machine number 55, and if you multiply that with 80 cars, we are almost close to 4,000 cars off the road.
That's absolutely.
So it has an impact environmentally, but of course we are looking at the whole picture. It has to be feasible financially for the brewery as well, and we've mainly focused at the financial part. It has to make sense for the brewery in terms of payback time and saving money. But the environmental part of it is definitely also important. And if politicians wanted to do anything about reducing CO2 emissions in brewery, this is the very low-hanging fruit.
Yes, I would agree. Reducing consumption is the number one way to reduce your emissions. And yeah, that's amazing. That's a really good statistic. So it's a great point to potentially end it on. Is anyone else got anything they would love to add in?
I just wanted to add, I mentioned before that our largest unit has a max capacity of 50,000 hectoliters. Our units are actually designed for seamless tandem operation, so you can actually, well, just match the amount of units to your production. So if you're above 50,000 hectoliters, don't be scared to contact us either.
I didn't think about the tandem. You can do the same with nitrogen generation as well. Yeah, so that's actually really interesting. I would just like to thank Frederik, Kim, and Jan for coming on the podcast. I appreciate it's a lot of time out of everyone's day, so I really appreciate that. And a big shout out to you guys for basically delivering what I think is one of the most exceptional bits of technology I've seen in the brewing industry in my life. It's really cool to actually have you guys on the podcast. I'm a big fan. So thank you so much from me and also on behalf of the brewing industry and the environment. So you guys are doing a stellar job. So keep it up, and hopefully we'll have this purchase CO2, let's call it an addiction within the brewing industry, gone in 5 to 10 years. That'll be pretty awesome.
Thank you for having us, Chris.
Yeah, thank you,
Yeah, thank you very much.
Well, thank you guys. I really appreciate everyone coming on. And for anyone who's listening, please don't forget to hit that subscribe or follow button. Never miss an episode of the Modern Brewer Podcast.